Oh my microphone. Um, my microphone mixer. It's too loud. It's too what? Ah, yeah, it is too loud. So let's put 55%. 1, 2, 3. Whoa! It's good. I am doing some experiment and see if I can stream on Twitch and YouTube at the same time. So let's see. View my channel. Oh, look at this. I'm doing it. Stream. I'm doing it. Oh, closed caption. Are closed caption working or not? 1, 2, 3. Testing. Testing. I do not know if closed caption is working. Doesn't look like they are working. Anyways, there is some delay. Let's test the chat. Would I get the message from the chat? No, I'm not getting the message from the chat. Oh, I did get message from the chat. Hey. But I'm not going to get the notification, unfortunately. I'm just wondering if I can make notification. Analytic Discord, filtering, appearance embedded in stream, reply command bot. Yeah. I'm not going to get notifications from YouTube, so I guess I need to periodically look, which I'm not going to do. Anyways, hello everybody. I do not know why this thing is not updated. I'm going to work on my game. No engine game. I'm doing it every day for last I do not know how much, so it is on endless. So the game called endless, it's not here. GitHub, endless drive. So game is here, and I started doing something with this game last week, January 12, 13, 14, 15, 16, 17, 18, 19, 20. So for 8 days. Oh, it's even so it's like 1 week and 1 day. And I have there is something. Some files are busted. Oh yeah, so I was doing some demos and I disabled vsync and also disabled. Maybe I should make this bounce smaller. Let's do like this. And I was thinking, people were wondering how fast it's going to be not in debug. So I made the release build. What's going on? Oh yeah, this thing is showing me stuff. Okay, so the game looks like this. So there is multiple things to do. There is a lot of things to do. I do not know what would be. Also, I have some ideas how to make the game better, like visually, and also as a gameplay. There is so many ideas. So I think I would probably do first brain dump, right? So let's go to doc. There is like a design document, and so I want to add what is this? So I can probably so let's separate this part. Set origin to geometry, and let's move this part here. Okay. So I want to add animation, then obstacle get consumed.
Animation, then obstacle gets consumed.
Right. Then angle car during the lane change.
Angle car during the lane change.
Add. I was thinking maybe make coins that would maybe make coins that would add to the score.
Maybe make coins that would add to the score.
Add lives. What's going on? So this is kind of game ideas. Set origin to geometry. So there is a UI, and for UI we need I need font rendering. I guess this is kind of one thing what I need for now, so I can later on find out what more I do need. So what I want to work. Let me make this simple thing. I can do it very quickly. Car CPP. So I want a car. Get road angle. Desired X. Current X. So this one would be dx const auto dx equals, and I want to put plus dx minus dx. So I'll find out what coefficients C would be. So this is very fast. Let me make it slower. And I do not understand. I thought I should do minus dx, but looks like I need to do plus dx, which is a bit confusing. No. I do need to do minus dx. Let's make it very, very slow just to be sure. What's going on? Oh, be right back. Yeah, maybe I should make it 10, and maybe I should exaggerate the angle. Let's see how it's gonna look like. I don't know, I'm liking how it's happening. Maybe it looks cool. I do not know, honestly. It's kind of weird. Yeah, maybe 10 is fine. Anyways, this one is... I do not know if I'm happy with it. Okay, I think it's fine. make car to turn towards the lane it is changing.
Make the car turn toward the lane it is changing.
PGFX font rendering. BGFX font rendering. Text rendering, I guess. Sign distance field. SDF rendering. Sign distance field, the industry standard for modern UI. Instead of storing pixel, the texture stores the distance to the edge of the shape. Crisp edges even then zoomed in significantly support easy effects like outlines and drop shadow or shaders. If you are implementing this in your project, the flow typically looks like this. Initialize creates a font manager. Load the true type font from memory to disk. Create handle. Generate font handle. Pixel size. SDF rendering. SDF text rendering. Let's look at the video. So this is the video. Done in many ways. Commonly, font textures used that contain most of the characters of the font. From each textile to the edge of the character. A small 512 texture. What the heck? Valve, Plastic Font Tool, Cinder. Discord. Let me put Discord in the streamer mode, so it would not make noises. Hey, Cooper Palak, hello. I am not going. I do not have any notification sound to see chat messages, so I essentially talking to myself. SDF. Oh, there is 16 minutes, 4 people watching. What? Who is watching me? That's interesting. Is it playing? Pause preview. The preview is kind of delayed. Good luck with whatever you're doing. Ever Cyan. Thank you. Yeah, I'm doing the game and currently trying to figure out the font rendering, because I'm making the game without the engine, so I don't have any luxury to render the font using the engine, so I'm trying to figure out how to do it by myself, and I'm trying to find out the ways to do it nice. And AI suggested there is a SDF rendering. and I'm wondering if I should do it. So I know how to do bitmap atlas, but yeah, this is the problem. I would need to have a lot of memory. Yeah, I can show my progress with that. I mean, there is a plenty of videos, but yeah. So there is my progress for now. There is no UI. I mean, there is a text here, but it's a debug output from the. So it's a debug output, so it's not a real one, and I want to get sort of a real good quality UI system. SDF rendering. So tends to lose the details and become rounded unless improve variant faculties post to pure brute force method, which can find here, has some great resource for creating and rendering SDF based fonts. So what is this? Contour check textures. This site is
This site is a distribution channel for software and documentation pertaining to a much improved distance transform method, particularly suitable as preprocessing for Green's hardware-friendly contour texturing method based on distance fields. The material presented here is highly technical in nature, and it is aimed primarily at technical developers in the field of computer graphics. Using the method for your own application will require experience and some programming skills. However, everything you need to know is available for free, including full source code. The software for new distance transform with documentation is available on the following external links.
there is a lot of mentions to Valve paper. So the paper is gone. Oh, this is advertisement. Qt implementation. All links are broken links. This is what 11 years does. Ew, it looks awful. In this pixel space, just calculate distance from course. Okay, but not that bad. And benefit not in it. I don't need free font either. Link to PDF. Page not found. All links are broken. Glyphy, sign distance field as PDF texture. Text render using OpenGL as shading language. Text render using shading language. Doesn't have license. Vimeo is alive.
Rendering. Thank you. Thanks for making time to be in this room instead of the big one. This is the end of the day, I know. I only have 150 slides to go, so feel free to interrupt. Okay, how to get your CFP accepted, a case study. So it helps if your project is established, has 100 million of users, has changed the world, it has a community around it, many high-profile users, and it's booming. Fail. If it's experimental, unused, will change the world in the future, no community, no users, and hasn't been touched in over a year, you will get access. So, next point. Submit. For those of us from the other hemisphere, most of the time the CFP ends while we are in the middle of GradX, drinking. So make sure you submit. And how to keynote NG.
Okay, let's see how active is this. 3 years ago was what made the commit. 2023. Correct string size, fix make. Okay, it's fairly active. And there is no license. License? Oh, there is a license, okay. Google license. Apache, oh, so it's Apache license, okay.
Licensed under the Apache license, version 2.0 of the license. You may not use this file except in compliance with the license. You may obtain a copy of the license at http://www.apache.org/licenses/license 2.0 unless required by applicable law or agreed to in writing. Software distributed under the license is distributed on an as-is basis, without warranties or conditions of any kind, either express or implied. See the license for the specific language governing permissions and limitations under the license.
Yes, or subject word for contribution grant copyright. Redistribution. You may produce distribute copies or you must give any other the copy of this license, and you must cause the modifier to carry prominent notice stating that you changed the file. You must retrain. It's kind of complicated license, but anyways. Video is free, right?
LCA, I was going to ask Matthew Garrett. Oh. Okay, so briefly, an experiment in GPU-activated text rendering with GLES2. So how do we render text right now? Basically, what we do is we modify these glyph shapes on the CPU for their transformation and font size. We rasterize it on the CPU, upload to a GPU texture, and play. The problem is, if you want to change the font size, you have to redo this again. So if you have animated text, you have to re-rasterize every glyph, every frame, upload it, render it, next frame. So let's do something better.
Oh man, did you notice this troll? Anyways, that's what do if you knew you could not fail have a high resolution display.
So the problem is many smart people have spent like 20, 30 years thinking about this problem. So if they couldn't solve it, why do you think I can? So something had to give, and we figured, let's figure out what can do better on high resolution displays. So when we started, we were thinking about 200 plus, maybe even 160. These days, the phone in my pocket has 445 dpi, so let's say 300 plus. So this is what we get from the font, an outline in Bezier's, second degree or third degree Bezier's, and our job is to transform this into pixels on the display. Now, what we have been doing for the past 30 years, everyone does on the CPU, is what we call coverage-based anti-aliasing. So basically, you draw the pixel on the shape, see what percentage of the pixel is covered, and you assign a number, a shade of gray based on that coverage. The problem is, again, you can only do it for the same transformation. So there's this other thing, SDF-based anti-aliasing, and I'll get to SDF in a second. The idea is, imagine the pixel is a Gaussian, it's just a hollow. Now, yeah, exactly. They used to be on the old displays. Now, with new displays, they actually are rectangular, but we're moving to this model now. But hold on a second, we get to that. Remember, we have 300 dpi. And if OLPC and Pentile could get away with rendering to those funky pixels that no one noticed, we're good. So now, if you have this pixel that is round and circular, and if you can find the distance to the outline, and this distance is signed, meaning it's positive if you're outside, it's negative if you're inside, then you can just assign a number based on the distance. That's sign distance field-based rasterization. So this is the sign distance field of the glyph. It's positive on the outside, negative on the inside. You pass it through a smooth function, you get your anti-alias rendering, right? The nice thing about this is you can make it blurrier or sharper. Shift it to get bolder or lighter. So, I know, but you can. Right. So the kind of smooth function you use changes the kind of anti-aliasing you get. The first top one assumes a perfectly rectangular pixel, and you're scanning aligned to the pixel. The second one is the smooth step function of OpenGL. It's basically second-degree continuous, but not at the corners. The third one is second-degree continuous all over. And the last one is the curve you get if your pixel is exactly 45% rotated. So even if you assume a pixel that is rectangular or square, you can mix between the first and last depending on the angle of the pixel. This is what I do, but makes no difference, really. You can't see the difference. So the nice thing about SDF is it is linear over uniform scaling and translation. So if you represent your SDF once, it's just linear math to scale and move the image. Now the problem becomes how to represent this SDF on the GPU. Now what problem so normally what people do, rasterize to a texture. This is kind of a rasterization, upload it, upgrade it. So when they want to use the SDF, they put the SDF on the texture. So you sample the SDF, put in a texture, on the shader, you bilinear interpolate the SDF. The problem is, again, when you zoom in, you get the same visual sampling effects. You lose sharp corners, you get bumps, it just looks bad. But game developers love it. So let's vector all I don't know if
game developers love
where, but so we want to put actual vector data on the GPU. So the problem, computing distance to Bezier is hard, really hard. Like for a 30-degree Bezier, you have to solve a 50-degree polynomial. Now again, like any other computer geometry problem, Jim Blin has a solution to it. There's a heuristic, but even that is too complicated, too complex, too heavy. So what we do instead is, So what you can do, convert to line segments. That's what we do on the CPU. It works fine, but the problem is you get this kind of thing again.
Yeah.
So the alternative I want to pursue is convert to circular arc splines. They look much better.
Okay.
So now we have a glyph, which is a Bezier spline. We want to convert it to an arc spline approximation, right? So first we need an error function. So this is your, say, curve, a circular arc you want to fit, and now I want to know how bad that is. So that I developed. Then I developed a physics simulation model to use as many arcs as necessary to achieve a certain tolerance. So this is kind of what you get, bunch of arcs.
Wait, what the heck is this?
And looks much better. This is all arcs. The number of arcs you get is about maybe 50% more than the Bezier, which is amazing. So GPU time. So stuff it all on the texture, ship it on the GPU for every pixel, find the closest arc. It's worked. First time I presented this, it was running at 3 frames per second, and each glyph took 50K of GPU memory. And, and I said, okay, I only need to make it 20 times better. And people asked me, the first question after the talk was, do you think you can do it? So people thought I was insane. So yeah, you're insane. So there's a lot of overlap corner cases to get those to just show up. There's like overlapping contours. If the two arcs are tangents, you can mess them up. They can cross each other. The float precision on the GPU. So yeah. So now what we want to do is to have fast random access to the closest arc. So what we do is we put a coarse glyph on a coarse mesh on the glyph. For each item, we just care about the arcs that may be closest arc to some point in this grid cell, and then various optimizations. So again, this is the line with the arcs, and the shade of gray here shows the number of arcs that may be closest here that we care about. So it's 1 most of the time, it's 2 sometimes. So this is a glyph. The green shade shows the number of arcs we care about. So you see around here, there's so many arcs that may be closest. In fact, no matter how fine you go, there are points that are closest to many arcs. But the nice thing about it is pixels are so small, we don't really care if something is 20 pixels away. So for these areas, we can just throw them away like this. So for this area, we don't care. It's just too far. Well, here, this is too far away from any arc. We don't care. So the shade here shows the number of arcs we care about. Here you see it's small. It's like 2 here, 3. And here you see one of the optimizations. If the closest arc is, there's only 1 arc and it's a line, we store it very efficiently. So you get the glyph again, and now the rhetoric changes. It's insane. So demo time. I don't know, you changed your shirt today. Okay, this is my system monitor. There's 4 cores, they still keep working, but glyphy demo. Well, let's make it a bit bigger so you still can see this. Okay, so this is like every single pixel, every frame is being rendered on the GPU, nothing on the CPU. The only thing the CPU does at every frame is, if you're animating, just change the uniform to set the matrix. So I can move it around. Oh, if I'm lucky, I can zoom it. Oh, I'm not lucky. Yeah, I can zoom it infinitely.
Moving further. Keep going.
Let me bring it on.
Round
Yeah, that's what I'm trying to do. Okay, you kind of see some artifact here. Okay, you proved your case. But no, the arcs actually don't blow away. So this is the debug info. You see the distance field, the number of closest arcs, the arcs themselves. You know, I don't know why the gamma operation is really bad. Anyway, so, and if we go back here, that may be the glyph shape. Here? Okay, here, right? Yeah, there's, yeah. that's just bits. I store x and y using 12 bits, and then the arc and line use different storage, so the line and arc don't line up. Okay, so back, zoom a bit, and the nice thing is you can have projective transformations. Okay, and the thing to notice is there's nothing happening in the CPU. Okay, so I'm getting ahead of myself, but so as I said, this is the SDF is invariant over a uniform scale. But if I scale it,
Man, I want it. I don't know.
okay, yeah, you see the anti-aliasing on the x-axis.
It's so
of the-
fancy.
We have a fix for that. So and if we see what kind of frame per second we are getting, yeah, something is capping at 60. I don't know what exactly. It can go faster, I'm sure. I have, but it doesn't help. That's the GLX thing. No, same thing. I used to get before GNOME shell and stuff.
Oh, GNOME shell.
Yeah. So what else can we do? Well, okay, you said don't do it again, but and of course we can get a oops. No. And can get outline for free.
Wow.
Okay. I think that's all I have. Well, gamma adjustment, contrast, all those things I can change.
Fancy.
Gamma, let's see. Yeah. Oops. Yeah. Good luck finding the right value. What's that?
When you went very thin, suddenly changed the layer. Yeah. Well, it's changing the gamma function.
Yeah.
He's not changing the thickness. Ah.
No, what's going on? What happened? Why everything frozen?
Couple sided.
Oh.
Problem is speed and memory are font dependent on every pixel, every frame. So font complexity is carried along onto every frame. So we say, yeah, if you have something like this one actually works. It's not much worse. But, no, that's something Museo isn't. But the problem is people do this. That's over 100 times more complex than your normal font. And when I try to render this one, the way I'm storing my stuff in a texture, I have a big texture, use it as an atlas with a width of like, I take 64 pixels wide and go down. This one needs to allocate more than a whole column. So I don't wrap and it just doesn't work. Advantages, memory footprint, as I said. So subpixel positioning is for free. Every pixel, every frame is subpixel positioned. Pinch to zoom is just normal. That's what this is designed for. So challenges. Talking to you, Eric. So shader size complexity. When I started this, people were like, you're crazy. There's no way. Shaders are not for this. Pixel cost. Again, when I was talking to one of the Android people 2 years back, they were interested. They said on Tegra, on some Tegra, we can afford, to get 60 frames per second, we can afford 1 texture fetch, 1 multiply, 4 adds. And I'm like, okay, I need 3 or 4 texture and 100 times the operations. Dependent texture lookup, again, people say it doesn't work, you can't do on ES2. So I need to look up something based on that, go look up some other things. That's how my grid works. So the first entry into the fragment shader, I see where in the grid this is, get it, go fetch the arcs, go through the arcs, right? So variable loop iterations, they told me like the loop has to have a fixed number of iterations, so fine, I cap it at 32 and break out of it. And interpolation accuracy, that's a more problematic one. So if I have variance passing from the fragment shader, the vertex shader to the fragment shader, and I'm using this for integer things, right? Those are like array indices and stuff. Looks like as soon as you have a projective matrix, like even if the variant is the same on all the corners, you lose 1 or 2 bits during the interpolation. So just don't use the lower 2 bits. So this is what people used to call a complex fragment shader. And
what?
It renders this.
Oh,
so
okay.
mine starts this way, like any good open source. This is a shader library. So you include the shader in your code and use it. So this is like the integration point. You define macros to integrate.
Huh.
This is how I access something. You define this to access your texture. This is my main SDF. This part is only the optimization. If it's a single line, if it's not close to anything, I handle it. Then I get ready for the actual for loop over the arc. And this is a for loop. Only, again, this is the optimization part. The actual going through every arc. This is the easy case, and this is the corner case. And finally, you just return them in this sense, signed. And it renders this, right? So drivers. Canon Worm doesn't start it. Okay, case study. Meta software render actually used to render this at some point. And then it started saying infinite loop detected in fragment shader. And Eric said, just forget about it. I'm not going there. NVIDIA on Mac has been so far the best driver for this, fastest. But again, every driver and operating system combination, we have to bring this up. I never got this bring up idea until I got here. For every single driver, we have to change things. And it's not like we were doing something bad. The driver was so broken. So in this case, apparently the shader compiler doesn't like token pasting. So I used to have token pasting so you could namespace my function in your shader, so I removed it. 150 plus frame on MacBook Air 2011. On the Retina, it goes about 30, so need some speed up there. AMD and Mac. Oh, the AMD compiler was even funnier. So this code here was never getting run, just moving it into a function fixed it. I don't know. Intel Linux, yeah, oh yeah. It used to just refuse to compile the driver, saying failed to steal registers. So Eric was nice enough to spend a lot of time and got this commit in. Do you want to
Convert live intervals, previous live intervals.
explain?
No, I really don't want to.
Basically, what was happening, if you had a loop, every variable access in the loop was allocated, registered, and retained for the entire life of the loop. So he just implemented some very basic compiler optimization things. And it's working. It's been working. Yeah, it was so hard. I had to keep one version of good Mesa around. So it runs 60 plus. I'm sure it goes faster. It's just my GNOME shell. It's a 2-year-old ThinkPad and stock Ubuntu 12 something 12.4. Again, full HD display.
It feels like a slow though.
iPad 3G, someone got it running on there. It's like, run slow, 3 frames per second. I still want to see it on 5.
3 FPS on iPod.
So Android 4.3, driver bike. So the red line of code used to correctly return 1. If I used an intermediate variable, it was returning 0. There was just no hope for this one. Fortunately, I just had to wait 4.4 fix it. So, well, I still needed a single patch. Like, this space here was if the space is there, the marker is not expanded. So, easy fix. And it's been running 25 frames per second on Nexus 4 and 5 at full HD resolution. I have it here if you want to walk over and test it. It also runs on the Nexus 12 2013. So, the code is in libglyphy, is C++ with a C header, it's like 2,500 lines of code, 300 lines of shader, no dependencies whatsoever, no OpenGL, no free type.
GLSL though.
It gives you a blob that you are supposed to take to the texture, and then you get a shader source, you integrate it in your own shader and push it out. So the Glyphy demo is about 300 lines of code. That's accessing the font, laying out, then getting the blobs, putting an app class, uploading, and using Cloud to drive the interactions. So subpixel rendering, we actually have it done. It's not much more complicated. So you just need to change your SDF to, instead of just returning the distance, return the vector, the direction to the closest arc. And then you have the direction, you have 3 subpixels, you approximate the distance of each of the subpixel centers. So it's not 3 times the cost even. And the troping anti-aliasing, again, we have something close to it. It's not complete. The problem is a circle, if you stretch it, it's not a circle anymore, right? And on the other hand, or the other way, the way we calculate the distance to the circle is we calculate the distance to the center minus the radius, right? That just doesn't work for an ellipse. So, but again, what we can do, we can get the vector to the arc, and then when we are dot producting that with the pixel dimensions, the pixel now has different dimensions in different directions. So you can kind of approximate that.
Yeah, I kind of
so
getting intimidated by all the stuff.
Because I'm going to show you what we have to go through to actually get this to work. And we are good in time. I can go through this in 5 minutes, I think. So this is a ladder. This is the SDF. That's with the parts removed, parts that we don't care about removed. So this is a very coarse grid. I can go finer and finer, throw some away, even finer. So you'll still have those bright spots. So this is the SDF. This is a DF, distance fill. I get the sign. Now, if you're not careful, you can mess up things. So if you have a point that is closest to 2 arc corners, now figuring out whether you're in or out can be tricky. So that was the first problem we had to solve. There's like tons of we had to solve 20 different issues to get it to work. So if you're not careful, all kind of crazy things happen. If you are careful, it's still some other crazy. This one actually is a font bug. The font has 2 points very, very close, which should actually be 1 point only. So, oh yeah, this is interesting. So if I want to just use the SDF, this is the SDF, it's around here, right? But we have a mode to do something called pseudo SDF, which produces these sharp corners. I'm not going to say what that's useful for, but I'm boldering. Okay, so again, artifacts. This is, if I remember correctly, float precision issues. If you're calculating the arcs, intersection, those things can go about more. Okay, now it starts getting funny, because you can get so close to being right, and then this one arc is totally wrong. So even this, okay, this is like, you see the discontinuity here. All kind of fun. Oh, this one again, see, it's almost right, but you get these two like flip. All kind of crazy things. I call this the spooky G. All over, like this one point happened to overflow, I think. Yeah, it was outside the bound of something, overflowed. Like all over, every one of these, like me or my intern had to spend days to figure out. And it's a GPU, you don't have printf, right? This is the Voronoi of the G, actually. Okay, and this is the patchy G. And that's all I have. Questions? And we have about almost 20 minutes. Go ahead.
Do you handle kerning?
Do we handle kerning? Yeah, so this is the thing. We don't do hinting, and you shouldn't really want hinting. But everything else, ligatures, kerning, funky contextual, those belong to the layout layer. So layout is Harpbus, my other project. So you give the text and font to Harpbus. It says render this glyph index here, and that's when the rasterization starts. So these are completely separate things. So yeah, we do that. Go ahead, yeah.
Have you done any benchmarking in the other direction of benchmark that keeps adding glyphs until you drop below CT?
So the question is if we have done more benchmarking, see how much we can put on it. So good question. The thing is, like, the main work on this ended a year and a half ago. The problem at that point was there was no target for this to work specifically on making it fast or major things. Because I don't see like the Linux desktop.
Okay, let's see. SDF sounds interesting, but maybe we have some existing libraries.
SDF sounds interesting, but maybe we have some existing libraries.
MSDF Gen, the modern gold standard. Nano VG. Use GUI. It has built-in font rasterizer. Present those common services. DRAM GUI. What the heck? Let me ask our AIs. Text rendering. Debug text front for UI and game text, scalable text, belonging to flexible font system. To example 10 font, example 11 font SDF. They do have font SDF. Yeah, I think I did see PGFX examples. Font SDF, yeah, there is a font SDF here. Low TTF. Yeah, look, Gemini failed. Put me in the rabbit hole, and here we go. Font manager, initialize font, shut down. Okay, let's look at the example. Third party BGFX examples common example 11. Fail to open text font. Find dot iname. So runtime. Oh, okay. It's not common. It's runtime. So 120 outline image. What the drop shadow. I'm not seeing. Oh, shadow color. So let's reduce alpha. See nothing. Rotate. Hey, it starts suffering. Huh. It is suffering. Oh. I think it's late already. There is source code. Let me still look for source code at least. That's interesting. But we do have 2 ways to font render in BGFX. So that's kind of interesting. So it's loading font. Example font init. So with settings, shutdown, update. So this is for GUI stuff, and this is the rendering. Takes setting up matrices. Text buffer manager, submit text buffer. Initialize font. Text buffer manager. So this is all the shaders. Um, do I want to do it this way? Yeah, I think I would go sleep and think about it. So it's 1300 lines. Plus shader scorn, and it's part of an example. So this is the bunch of shader code. Oh, what the heck is this? GLSL, huh? So they just baked it. In the binary, so you can just build it, huh? This is the shader cone. This is not. So fragment shader is kind of small. Shadow. Yeah, this is. It's not too big. But this is the fragment shader. How about vertex shader? Ah. So apparently all complexity is in the code. Also, I wasn't very happy about the performance, like drawing. So I think I will go with Atlas approach. So just to make the Atlas. So let's say we would have each character 100 by 100 times and square root where is the square root? Yeah, this is ginormous texture size. But what if we do 50 by 50 square root? Still very big. So let's see 8K by 8K divide by 65 and square root. So 31 by 31 pixels. Right, so this is the, and if I put the character here, M, so 25 Yeah. So I guess not rendering every single character would help. Anyways. Anyways. Did not write too much code today, but we watched some videos, read some articles. I watched some videos, I read some articles. Made like a small commit, little bit of code, but I need to figure out what to do with font rendering, and I don't think I would need to do very sophisticated UI system. I think if I can just find out a way to render text, it would be good enough. Maybe adding some images, so for icons, and yeah, images. It's simple. The font one of the most complicated stuff. And yeah, after this I can just make some UI, have like a start screen, title screen, then some menu, like keyboard interactions. Yeah, I think I need to, like, the thing what I'm worrying is skeletal mesh. This is kind of interesting challenge. It's not needed for this game. Oh, what's going on with my... Oh. Some skeletal mesh and animation.
Scale mesh and animation.
Skeletal mesh.
Skeleton mesh and animation.
Yeah. So that might be challenging. But now let's focus on the font rendering. Anyways, it's almost 10:20, 10:30. 10:30. Let's go to bed. Thank you for watching, guys, and hopefully see you next time. Bye.